3.1 notes. It is going to be over parallel, perpendicular, and skew lines. Two lines that do not intersect are either parallel or skew. Two lines are parallel lines if, and this should say they, if they do not intersect and are coplanar. So remember again, coplanar means on the same plane. So to be parallel, they cannot intersect and they have to be on the same plane. We refer to lines as being skew lines if they do not intersect and are not coplanar. And I'll show you an example of those in just a second down here on the diagram. So two planes that do not intersect are parallel planes. So just like we have parallel lines, we can also have parallel planes. A unique plane can be created by connecting three non-collinear points with two different lines. So basically what this is saying is a unique plane means a plane that you draw yourself by connecting three non-collinear points, because remember, any three non-collinear points can make a plane. Also, we have perpendicular lines, and hopefully we know perpendicular lines always form a 90-degree angle. So just some symbols that we need to kind of get used to. To symbolize parallel, it's like a crooked 11. That's the symbol for parallel. So just think of the two L's in the word parallel, and they're kind of sideways. And the symbol for perpendicular is an upside down T. So you need to make sure you know the difference in those symbols and how to read those back to me. Okay, so let's look at the examples so you can kind of apply this whole parallel plane, parallel lines. In this example, it says, think of each segment in the diagram as part of a line. There may be more than one right answer. So I'll try to go through a couple of right answers so you can see different examples. Name a line perpendicular to BF. So if we look at BF, that's this back of the box, basically. It wants to know, okay, what is perpendicular to BF? Well, right here at this corner of B is a 90-degree angle. So BA is going to be another line that is perpendicular to BF. Also, you can jet out the other way from B and say, okay, BC is perpendicular. We could also use the other side. We could use F, and we could say our FG or FE. So all of those would be perpendicular to that line, BF. Now let's look at name a plane parallel to plane ABC. So remember, a plane you only need three letters, but it does not mean that those are the only three letters on the plane. Because if you look at points here, A, B, and C, all right, they're on this top of the box, this plane. You don't have to include that letter F, but that is the whole entire plane. So if we want to name a plane parallel to this one, remember parallel is not touching. So since we're talking about the top of the box, then what would be parallel to it? The only piece that's not touching there is the bottom of the box. So again, to name that plane, you use any three of those four letters. It doesn't matter what order. I'm going to say that is plane EFG. Okay, now our lines CD, so let's look at CD right here, and FE, which is in the back here. So basically you have to be able to really see this, three-dimensionally, and know that CD is kind of sticking out in front of you, it's closest to you, and FE is way in the back of the box. So they want to know if these two lines are parallel, perpendicular, or skew. So right away, a lot of kids say skew because they don't look parallel and that they're not perpendicular. But remember this whole thing we talked about up here, this unique plane can be created by connecting three non-collinear points. So basically what that means is that if you have three non-collinear points, which we do here, see we can say C, D, and E. we can make our own unique plane. So if I were to like slice this box from D back to E and from C down to F, I can create my own plane, like cutting this whole thing in half. And it would slice it in half. So then that makes those lines parallel. Because remember, the definition of parallel is that they never intersect and that they are coplanar. Well, since you just drew your own plane, connecting them and cutting that box in half, then you can say that they're parallel. Alrighty, next one is name a line parallel to EF. So if we look at EF, all right, EF is this line here in the back. We want to name a line parallel to it. Well, then right away, here is this one in the back. Then we could also say right here that AB is parallel to it. That's kind of the top of the back. You know, you have a bunch of examples here. You could also say GH. GH is parallel. And you could also say, like what we just said in the one before, CD is parallel. Name a line that is skew to AE. So if we look at AE, it's right here. So skew is basically, it's not parallel, it's not perpendicular, it's not on the same plane, and it's kind of going in a totally different direction. So you see AE is way in the back of the box here. If we say, all right, what about GH? So see how one is vertical and one's horizontal? They're not on the same plane, so they'd be referred to as skew. We could also use CD here, the front of the box. Okay, what else? You could use this GD going back and forth right here if you wanted to. So there's a few examples for you. So those are parallel lines, perpendicular lines, and skew lines. So now to talk more about, more specifically, some just in general lines, we also are going to introduce a new type of line called a transversal. A transversal is a line that intersects two or more parallel lines at different points. Okay, and a transversal, the lines do not have to be parallel. As you can see in our diagrams here, a transversal can also intersect non-parallel lines. And next time we'll kind of learn what you can do differently if they are parallel and what you cannot do if they're not parallel. So for today, we don't have parallel lines here. We're going to just talk about the transversal with the non-parallel lines. So what happens here is when you have two lines, like we do in this first one, see we have two lines, they're intersected by this transversal, and you can see it's named T. Now, within this whole intersection, look, now there are special angles being formed where that 2 and that 6 are sitting. But basically, when you have these two lines in a transversal, now you have 8 different angles that are sitting there. So they all have special names. So the first one we're going to talk about is right here in 2 and 6, and those are referred to as corresponding angles. Corresponding angles have corresponding positions. So corresponding kind of means they're in the same location. They have a lot in common. Okay, angle 2 and angle 6 are both above the line. So you can see like 2 is in this on top of the line, and 6 is on top of the line, and it's also to the right of the transversal. So if I were looking at each of these as a four-way intersection, I would say that 2 is in the top right and 6 is in the top right. So if they're living in the same spot, okay, they're just kind of basically in different subdivisions, but they live in the same spot, corresponding. The next type are referred to as alternate interior angles. So again, what is built in this name is exactly where the angles are positioned. Think about the word alternate. Alternate means like from one side to the other, okay? Like it alternates back and forth, back and forth. Interior means inside of something. So alternate interior angles are two angles that lie between the two lines. So you can see here they're in between the two lines. And they are on opposite sides of the transversal. So that's where that whole word alternate comes in. Do you see how 5 is on the left and 4 is on the right? So they alternate sides of the transversal. They're flip-flopping back and forth, but they're inside the lines. So of course, if we have ones inside the lines, we're also going to have ones down here that are outside the lines. So two angles are alternate exterior. If they lie in outside, sorry, these are the outside. If they lie outside the two lines and are on opposite sides of the transversal. So you can see that again. The word alternate means from one side to the other. So this angle in this position is on the left, and this is an angle here on the right. They're both on the exterior of the two lines. So we refer to those two angles as alternate exterior angles. The last pair we have are referred to, these are going to be consecutive interior angles. So two angles are consecutive interior angles if they lie between the two lines and on the same side of the transversal. So sometimes these are referred to as the same side inside angles, okay? Just because it rhymes a little, same side inside. Because if you look at them, they're inside the lines and they're on the same side of the transversal. And again, consecutive, think about when sports team, they win championships back to back. That's called consecutive championships. So they're one right after the other. Now what we're going to do is look at this bigger picture down here and kind of see again all the different angles and again apply all of these names to the angles. So these are all names, so new words, new definitions you're going to need to know. Again, corresponding angles, alternate interior, alternate exterior, and consecutive. Okay, so in this example 2, you're going to identify a pair of angles of the given type. And like I said, you see here we have two lines going this way, and then we have two lines going this way. So basically what you can do is that if you need to cover up kind of this side and only look at these, you can. Because here's going to be, there's one line, there's the other. So those are the two lines being cut by this transversal. So we'll just say that's transversal number 1. Then we can also have, okay, here are two lines, here's another line cutting through both of them. So this can be transversal number 2. So you can have more than one transversal cutting through the same two lines. Let's look for, we need to find corresponding angles. So again, I left all of this up here so you can look back at your notes and say, okay, well, corresponding angles. Corresponding are the ones right here that they live in the same spot, just a different intersection. So basically just pick an angle. So if you picked number 1 right here, I always say this is like a 4-way stop. You have 4 different angles here. Basically we have 4, right, 8, 12, 16 different angles in this diagram. So if I'm right here at 1, of this intersection, I'm in the upper left. So if I go down to this intersection and I want to stay in the upper left, I'm going to hit it number 9. So corresponding angles are angle 1, and angle 9. Okay, we could look at another example. If we went over here and said, okay, I'm going to pick number 8. Of this 4-way stop, it's in the bottom left. If I go down to this other intersection, bottom left is going to be 16. So another example would be angle 8 and angle 16. Okay, alternate interior angles. So that again is up here like 4 and 5. So they're alternate. They're flip-flopping the side of the transversal, but they're inside the lines. So basically we're in here. We're on the interior of the lines. okay? Let's just pick one angle on the interior. So if we start here at 4, it's on the inside. Well, now I've got to alternate. I've got to flip-flop to the other side of the line, 10. So 4 and 10, right here, 4 and 10 are going to be your alternate exterior angles. Okay, and we can pick another one from over here. If I pick 7, if I alternate to the other side but stay inside, then I'm going to have right here 7 and 13. Alternate exterior angles, this picture here, 1 and 8. So now you're on the outside of the line. So we're looking kind of up here at 1, 2, 5, 6, and down here at 12, 11, 16, 15. So we're just going to pick one on the outside of the line. So we'll pick 6. Now we have to go all the way outside and flip-flop the side of the transversal. So if we're at 6, that's going to travel all the way to 16. So 6 and 16. Consecutive interior angles are these guys here, same side, inside. So I'm looking inside, but I have to stay on the same side of the transversal. So if I just pick 3, it's inside, I got to stay on the same side. I got to be consecutive, one right after the other. So angle 3 and angle 10. Another one, if you just wanted one more, if you picked 8, consecutive right here, 8 and 13. Now those aren't the only examples. The ones I listed, those are just a couple out of the diagram.